Welcome to discussion 15. In today's discussion, we'll be focusing on section 3.5 on implicit differentiation. In this video, we'll do some practice problems involving finding the tangent line at a given point when we have to differentiate implicitly. So I want to look at worksheet 7, problem number 1, and have you try parts A, C, and D of this worksheet first. So give yourself 10 minutes to try these problems. 4, 3, 2, 1. Pause the video and try these for about 10 minutes total. Alright, so hopefully you did that. Hopefully you paused these and tried them for about 10 minutes. Let's talk about them together. So for part A, we have this equation x squared plus y squared equals 100. At this point, negative 5 comma 5 root 3. So I want the equation of the tangent line to that curve at this point. So first, what I should do is I should check if the point is on the curve. Because if it's not even on the curve, then my derivative would not be defined, and I wouldn't have a tangent line at that point, because that point is not on the curve. Okay, so if I plug it in, I get negative 5 squared plus 5 root 3 squared, and I want to know, does this equal, so I'll put a question mark, does it equal 100? So negative 5 squared is 25, and if I square 5 root 3, we'll get 25 times 3, because we square each of those terms. So does that equal 100? Well, yeah, because this is 25 plus 75, and that does equal 100. So I'll put a check mark. All right, so it's always good to do a preliminary check when I'm differentiating implicitly, and it gives me a point to find the tangent line equation at. Make sure that point is on the curve. All right, so now we will do implicit differentiation. Implicit differentiation. All right. So remember that we can use implicit differentiation in situations where our variable y isn't isolated. Okay, so what we do is we begin by taking the derivative on both sides. So I'll take d dx of both sides. All right, so on the right, we'll have d dx of 100. On the left, we'll have d dx of x squared plus y squared. And let's start it off with the derivative of the right-hand side, because that's easier. Derivative of 100 is just 0. On the left, derivative of x squared is just 2x. But remember that when I do the derivative of y squared, when we do this, when the variable in our function, in this case it's y squared, is different from the variable that we're taking the derivative with respect of, in this case we're taking the derivative with respect to, or I should say derivative with respect to x, and those variables are different, then I am going to think of y as a function of x, and when we do that, we can rewrite the y as being y of x, y is a function of x, and we're going to square this. And now let's take the derivative. So if I take d dx of this, well, now I don't just have x squared, I have some stuff squared. So I need chain rule for this. Chain rule says we'll deal with the outside thing first, the power. The power comes down, and I'll get 2 times y of x to the 1. So I don't really need to write the 1 there. But then the chain rule says, okay, now multiply by the derivative of the inside. And the derivative of this function y of x is, I would just write that as dy dx. Okay, so the derivative of y squared is going to be, I'm going to replace the y of x with just a y. We'll get 2y. And then we do the chain rule, and we take the derivative of that y, which is dy dx. All right, so now let's isolate the dy dx. So we get 2y dy dx. If I subtract 2x, this equals negative 2x. And then we could divide 2y to get dy dx equals negative 2x over 2y, which simplifies to negative x over y. All right, so we have our derivative. When we do implicit differentiation, it will usually involve both of the variables. So now let's write down our point and our slope, because we'll need those to write the equation of the tangent line. Remember, the point was given to us. Let's see, it was x coordinate was negative 5, and the y coordinate was 5 root 3. And for the slope, we need to plug in our point into our derivative. So we got to take a dy dx and evaluate it at the point -5, comma 5 root 3. So if we plug those values in, we'll get negative. X is -5, and then the y value is 5 root 3. And this simplifies to 1 over root 3. And that's going to be my slope. So now we could write our equation. So our equation, let's put this in a different color. Our equation using point slope form is y minus the y coordinate, 5 root 3 equals m, our slope, 1 root 3, times x minus the x coordinate. But when I subtract -5, I'll get a double negative, which becomes a plus. So let me just replace that with a plus, x plus 5, and that is our equation. All right, let's do the next example. So part C, we have e to the y over x plus 1 equals x at the point 2, 0. So as before, let's check if the point is on the curve. Check if the point is on the curve to get it started. So we will plug it in. So we get e to the y is 0, x is 2, and then plus 1. And I want to know, well, question mark, will this be equal to x? And my x value is 2. So I have e to the 0, which is 1. 1 plus 1. And that definitely equals 2. So I put a check mark. Our point is on the curve. All right, so from here, because our y isn't isolated, we can use implicit differentiation. Implicit differentiation. So we're going to take the derivative of both sides. So we will take d dx of the whole left. And that's going to be equal to d dx of the whole right. All right, on the right-hand side, we have x. On the left-hand side, we have e to the y over x, and then plus 1. All right, so let's do the derivative of this e term. So I don't just have an e to the x, I have e to the stuff. So this is going to be chain rule. Chain rule says, well, derivative of e to the stuff is, start off with e to the stuff, but then you multiply by the derivative of that stuff, of the exponent. And for the derivative of the exponent, well, that's a fractional thing. I'm going to need quotient rule. Okay, so let me leave myself some room for the quotient rule. Quotient rule says low d high, so low is x. D high is going to be the derivative of y, which I read as dy dx, and then minus high d low, so high is y. D low is just going to be 1, because I'm taking the derivative with respect to x. All right, and then all over low squared, all over the x squared. All right, and this is going to be equal to d dx of x, which is just 1. All right, so we have taken the derivative of both sides. Now let's isolate dy dx. To do that, I'm going to multiply this x squared that's on the denominator over, and then divide by the e to the y over x that's factored out. Okay, so if we do that, we get x dy dx, and then minus that y will be equal to x squared when I multiply it, and then I divide by the e to the y over x. All right, so continuing to the top of the next page, we have this. So now let's isolate the dy dx term. I'll add y to get x dy dx equals x squared over e to the y over x, and then plus y, and now I divide that x. So dy dx equals this x squared over e to the y over x, and then plus y. Now we're dividing that whole thing by x. That's my derivative. Now we're ready to write down our point and our slope. The point was given to us. It was 2, 0. And for the slope, we need to take the derivative and evaluate it at that point at 2, 0. All right, so I'm plugging in 2 for the x. So I'll get 2 squared over e to the 0 over 2 plus y plus 0 over x, so over 2. And if we simplify this, this first fraction becomes 4. And the denominator is 2, and 4 over 2 is just 2. All right, so we are ready for the equation. for the equation now. We get y minus the y coordinate, 0, of the point equals m, which is 2, times x minus the x coordinate, 2, and I got my equation. I got my equation in point slope form. All right, let's do another example. Let's do part D now. All right, so D had the exact same function, or sorry, exact same equation, but the point is different. So it might be really tempting to say, wait, I got my derivative. Why don't I just plug 4 comma 0 into that straight away, and then I'm going to be ready to have my point and my slope, so I can write my equation. But we're forgetting something if we do that. And what we're forgetting is that we need to first check if the point is on the curve. Check if the point is on the curve, because if it's not, then I can't take the tangent line at that point. All right, so if we plug it in, we get e to the 0 over 4 plus 1, and I want to know if that's going to be equal to the x value, which is 4. All right, so this is 1 plus 1, and does that equal 4? Well, no, because the left-hand side is going to be 2. So because of that, our point here, 4 comma 0, is not, it's not on the curve. Okay, and if it's not on the curve, there's no such tangent line. Because the problem didn't say, like, draw a tangent line that goes through that point. We've seen a discussion video where we had some curve and there was some point that was not on the curve, and we were interested in finding a tangent line that goes through that point that's tangent to the function. But that's not what's going on here. The wording of the problem is assuming that that point is on the curve, but in this case it wasn't. And because of that, I can't draw a tangent line like this.